Okay, so Sally and Bob are standing atop two different watchtowers in a national park. Sally's location is, so these are coordinate pairs, so I'm going to have to create a Cartesian plane and then insert Sally and Bob's locations. Sally's location is at 212. I'm going to label them on the axes to keep my numbering out of the way. And Bob's location is 3, 4. So this is Sally, this is Bob. They both spot a fire off in the distance and measure the angles between the watchtowers and the fire to be, well, before I go there, let's kind of give you the picture. The problem came with a picture. I just didn't like it, so I'm going to write my own out. So Sally's standing here, Bob is standing here, and someplace off in the distance, Sally sees a fire and Bob sees the same fire. And so we're going to call that point F. And from Sally's perspective, the angle between her view of the tower where Bob is and the fire is 15 degrees. Again, there was a picture, so I know I'm labeling correctly, even though there's nothing in the words that would tell me that. And 25 degrees. So 15 and 25 degrees, I'm looking for the fire, and I want this in ordered pair format. So let's put everything I know. Well, I know that if I have a triangle with an angle 25 and 15, that these total 40, so this angle has to be 140, 180, take away 40. Then I also can find the length of the distance between of Sally and Bob by using the distance formula. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And since this is not an Algebra 1 class, I'm not going to make you watch me pluggy-chuggy my way through it. So I've already set up on the calculator that the solution is, or the distance is, root 65. So we know that the distance from Sally to Bob is root 65. And I see I've made a mistake here on my angle. It's 140. Not sure why I wrote an 8, but oh, I did it again. 140. Okay, I think we're good. So let's think this through just a little bit. If I could find the distance, the horizontal distance from point B to point F, and then find the vertical distance from point B to F, I would be able to put together a rise over run scenario that would let me figure out exactly the coordinates for F. The problem is I need this angle to do that, to find a Y and to find an X, but I don't have that angle in my diagram. If this were a 90 degree here, then I would just have 90 take away 25, but it's not a 90 degree. I need a way to find the rest of this 180 degrees in an angle. Luckily, because I'm on the Cartesian plane, I have lots of distances to work with, and I can find the measure of that angle. So I have a 90 degree, and across from it I have 65, or root 65, and then I have some unknown angle. And across from it, I know that my elevation goes from 4 to 12, so this side length is 8. So I'm going to use the law of sines, and I'm going to say that I'm looking for angle P. So the sine of angle P is to 8 as the sine of 90 is to root 65. Sine of 90 just equals 1, so I don't have to deal with that. And so I can say that the sine of P equals 8 times the root 65. Well, I'm looking for P, not the sine of P, so I don't even need to calculate that. I'm just going to change this to the inverse sine of 8 times root 65. Let's see if I can write that better. And that's going to give me the angle P. And if only any of what I just said were true, we'd be in really good shape. I bet you caught my mistake. So sine of P is to 8 as the sine of 90 is to root 65. Okay, we're ready to go now. So that means that the sine of P equals, well, we know that sine of 90 is 1, so that's 8 over root 65, and so P is equal to the inverse sine of 8 divided by root 65. And again, you don't need to watch me calculate. I've already loaded it in. So this is 82.875. So I know that this angle is, if P is 82.875, this angle is 180 minus 25 minus 82.875. Now, a part of me wants to, because we're talking about long distances, right? We're talking in miles probably. And so a part of me wants to go ahead and round this to 83, but it's always dangerous to do that too early in a problem. So I'm just going to carry the 3 decimal places with me. So I know that this angle equals, by the magic of technology, 72.125. So I'm ready to use Pythagorean ratios. I have y equals r sine theta, where theta in this case is going to be 72.125, and x equals r cosine of theta. Problem is, I don't have my r value yet, and in this case r represents the hypotenuse of the triangle I'm using, of the slope triangle, this right triangle, but I do have the original triangle with all the original information, and I can use that to find the length from B to F. So let's use the law of sines again. Let's say that the length from B to F is 2. So this is the side length I want. I'm going to use sine of 15. In the same way that the length root 65 is 2, across from root 65 is the sine of 140. Solve for BF equals root 65 times the sine of 15 over the sine of 140. And that is 3.246. So now we have every single thing we need to find y and x. In fact, I've already loaded them in again. So the hypotenuse times the sine of the angle we're working with equals 3.00931. And of course, that's approximate. And I want to use 3 decimal places because that's what I've been using. So this is going to be 3.09. And then for x, I have 0.996. Now that seems kind of weird to me, but let's go ahead and put in the points and decide whether there's some logic to it. So I think that the location of f is starting at B on the x-axis, 3 plus 0.996. Actually, I'm going to go ahead and round because 0.996 is so close to 1. So 3 plus 1, I'm going to call that 4. And then on y, I'm going to go 4 plus 3.09, I'm going to call that a 3. So 4 plus 3 is 7. So I'm saying that I think the location of the fire is at 4, 7 on the plane. Now let's do that logic check just to be sure that this really does make sense. So if I draw Sally and Bob, and I've put them in the vertical because they're looking at each other and a fire, they're not really on a Cartesian plane, so the angle doesn't matter. And Sally, I know, is at 212. And Bob, I know, is at 3,4. So if Bob is looking about 25 degrees, I'm going to say that's about that. So I'm going to say that this is about a 25-degree angle. And that's roughly what I had to begin with. But Sally, this is clearly not 15 degrees. If this is 25, then this couldn't possibly be really 15. So if this is 25, something more like 15 is going to be like that, sort of. So the fire we're saying is here, and we've calculated that the fire is at 4, 7. So to go from 3 to 4, that's 1 unit over and 3 units up. And to go from 2 to 12, that would be 2 units over and a bunch more units up or down. So really, if I make my angles more like reality, I get a picture that's more like what would make sense to me. So I'm feeling pretty good about this solution. I'm going to say we're done.